Zehua Zhao, and this will be my video for homework 3. Before we start, I will show you my room to ensure there's no cheating hiding around. And here on my desktop, it's the problem statement that's being opened. I will reference it and only it in the following solution. So now, without further ado, let's get started. So after reading the statement, we know that these two double slit and single slit situation have a overlapping dark fringe. And however, the bottom has a dark fringe in the center of the interference instead of a light fringe. This means we can't just go by counting from 0 to, well, whatever there is in order to find out an nth term for the dark fringe in double slit, which means we can't just set up two different equations with a sine theta equals to m lambda equals to d sine theta equals to n lambda divided by d. That is not possible. However, we can count the fringe spacing because between two fringe, the spacing in either double or single equals to L lambda divided by D, or well, A in the other case. So we're going to now use this formula. So first, for the single situation, the single situation, we know that A sine theta equals to m lambda, and for single, this is the first dark fringe. So we can still say that, oh well, this is m equals to 1, which will give us A sine theta equals to lambda, which then gave sine theta equals lambda divided by A. And since this is long enough, the distance L is big enough that we can just say the hypotenuse and the adjacent side is basically the same thing over here. And this would then mean that L sine theta equals to 2 L sine theta, since L sine theta is half of, well, delta y is the spacing, and 2L, what the hell? Yep. This will be what we're getting from there. So first, we know that what sine theta is. Then we know that the spacing is 2 times of the L sine theta, which because it goes from the middle to the top and to the bottom. And this is 4.8 centimeter, by the way. We're not going to use it now, but this number will be important a bit later on. This would eventually give us this equation, which is very helpful. Going to the double case. Each individual slit over here is individual slit equals to L lambda divided by D. And in total, we can start counting how many fringes spacing there is. Let me see if I can. Yep, it's good enough. Now we zoom in, right? This is 1, 2, 3, 4, 5, 6, 7. So we counted 7 in this area. What this means is 7 of these individual fringe spacing, 7L lambda divided by D equals to 2L lambda divided by A. So here we have an equation to give us a relation between lambda and, well, not lambda, between D and A. Do a little bit of operation and simplification. This will give us equations that A equals to 7A equals to 2D. Excuse me. And we seem stuck here, but we could know that D plus A equals to 250 micrometer, which is given. This gives us D equals 250 micrometer minus A. Thus, 7A equals 500 micrometer minus 2A. With 9A equals 500 micrometer and A equals 500 divided by 9 micrometer. We're just gonna leave it here because it's just a messy number and opening it up doesn't really help. Keeping it like this reduces the error during calculation. And we don't need to worry about the messy rounding issue. Now, we have A, right? Plugging A back into the previous equation, because we know the total spacing is 4.8 centimeter. So 2L lambda divided by A equals to 4.8 centimeter. Now, this coming to factor. L, as we know here, it's 2.00 meter. And A, we just calculated it. It's that fraction. A little bit simplification, we will get lambda equals to 0.048 meter. We rounded and we converted it into meter instead of centimeter. Divide by 2 times 2 meter, it's 4 meter. Equal times plugging A to the top, it's 500 divided by 9 micrometer. So now we don't want to convert the unit of A, because the unit in the fraction between 4.8 centimeter and 0.048 meter and divided by 4 meters, this is going to cancel out and give us a ratio. This ratio times the original A is going to give us lambda in term of micrometer. And this is, in my opinion, much easier. So 0.048 divided by 4 times 500 divided by 9. It gives us lambda equals 0.667. I'm gonna round this 3 because most of the stuff are given in terms of 3 significant digits. And now we have lambda. Afterward, it should be easy because remember, there's two slit, right? And since we treat each slit as its own source, the wave passed toward it and passing through these two different slits. One has a filling and one doesn't. This is going to cause a difference in phase. So phase difference is essentially, let's see, phase, I'm going to call it 2 for the one with glass, minus phase 1. So what is phase 2 going to be? Phase 2 of it passing through this thing Let's call the sickness tau. Phase 2 passing through tau is k tau equals to, let's call it k prime. K prime tau equals to phase 2. And the one just passing through, well, just an empty space would give us phase 1 k tau. Since, well, sickness is the same, right? They're the same board, cut it at 2 different openings, equals to 1. So here's the relation, right? You can see over here, the equation and each individual one. Now, this is gonna give us delta phase equals to take out 2 pi first, because k is always 2 pi divided by lambda. So it's 2 pi tau lambda prime minus tau divided by lambda. Well, you actually need to plus like the phase shift difference here. This is the equation, but phase shift here is 0 because they all come from the same source, right? It's only when there's 2 different sources we consider if there's a phase shift difference. These are from the same source, just after experiencing different, well, past difference, I guess I could say, after passing through different material. So ignore this part. We only need to consider this part during this question. A little bit more simplification after this give us that delta equals to 2 pi tau divided by n minus 1, since using this identity over here, we will get this final equation. And now we've simplified out the refraction index, refraction index, yes. With this over here, it's a pretty simple calculation. We just plug and chug. Notice that in the middle of everything, it's a dark fringe, which is destructive interference. For destructive interference, phase difference must be 2n plus 1 pi. And for this to be the lowest, we set n equals 0, so it equals to pi. So phase difference is pi. Pi equals to 2 pi tau divided by lambda n minus 1. And a little bit simplification, we get lambda divided by 2 tau because pi cancels out, plus 1 equals to n. Look at here. This is the equation we're going to use. And I'm going to move everything to the left just so calculation become a bit easier. Tau is actually given. It's just 1 micrometer. So it's 0.667 micrometer divided by 2 times 1 micrometer. Pretty convenient number, I will say. Notice every unit cancels out, so this is just a ratio, which is, again, correct. After punching whatever the heck is left here into the calculator, we will get n equals to 0.667 divided by 2 times 1 plus 1. 1.335. 1.3335, sorry. Here, 1.3335. I guess I'll say it's 1.334 for the sake of sig fig. Over here, yeah. And that will be it. Thank you for watching my video. This is my solution for homework 3.